You are welcome to my physics class today, and the topic we want to have a look at is current electricity. What is current electricity? Current electricity simply means study of charges in motion. Study of charges in motion. When charges are in motion, we call that process current electricity. But what about when the charges are at rest? What do we call that? That is not current electricity. When charges are at rest or static or stationary, we say that the study of that charges at rest is called static electricity. Static electricity, which is also called electrostaticity. That is also part of the topics in SS1, which is year 10. So, the charges that we are dealing with under this concept of current electricity are called electrons. Though we have two types of charges, we have the positive and we have the negative. The positive charges are called protons and the negative charges are called electrons. Under static electricity, that is, charges at rest, we deal with both of them, that is, positive charges and negative charges. But under current electricity, it's simply based on electron. Why? Because it is the flow of electron that causes electricity flow. That means electricity cannot exist if the electrons are not in motion. And the unit of charge is coulombs. Any type of charge, either positive or negative, the unit is what? Coulombs. All right. One thing you need to take note of is that it is the flow of electron that causes electricity to flow. That means no electron flow, no electricity. But there is one thing, which is this: the direction of the electron and the electricity are always opposite. That means if electron is flowing in this direction, as the arrow indicates, electricity is flowing in this way. Let's take note of that, because we may need that knowledge under another topic. Now, for electricity to flow through a circuit, then it needs something to drive it from one point to another. And what is that thing? That thing is called potential difference. Potential difference. It is that potential difference that will make the electricity to flow. It's a driving force. Yes, that makes the electricity to flow from one point to another. What is now potential difference? What is potential difference? Potential difference, which is also called voltage, is simply defined as the work done per unit charge. Work done per unit charge. What this means is that a work has to be done on the charge before it can flow from one point to another. So the amount of work done on a charge, that is on one charge, that is, unit means one. The amount of work done on one charge is the potential difference of voltage. And that means from this definition, we can bring out a formula that potential difference is equal to work done over charge. Don't forget, work done is measured in what? Joules. While charge is measured in what? Coulombs, which we have mentioned in the previous note. That means unit of potential difference from this formula is joule per coulombs. Joule per coulombs. But meanwhile, the standard unit, that is SI unit, which is recognized universally, the SI unit of potential difference is what? That is volts. Volts. We use small letter V to represent it. So whenever you are asked for the unit of potential difference or unit of voltage, you mention volts. But the equivalent to the volt is joules per what? Coulombs from this formula. Work done is in joules, charge is in coulombs. Now, it is about time we talked about the charge itself. We've been mentioning charge. What is a charge, or what are charges? A charge can also be referred to as quantity of charge. So don't be confused whether you hear charge or you hear quantity of charge. And what is this quantity of charge? It is defined as a product of the current and the time taken. Now, from this definition, we can bring out a formula that quantity of charge is current times what? Time. From here, we will talk about current. Since we are dealing with current electricity, we will bring out the definition of current from this formula. Do not forget that in the previous note, it has been stated there that unit of quantity of charge or charge is what? Coulombs. Coulombs. Unit of Q. Unit of that quantity of charge is what? Coulombs. With capital letter C. Coulombs. But from this formula, we can infer that unit of quantity of charge is the same thing as amperes times seconds. That is amperes seconds. Amperes seconds. Why? Because current is measured in ampere, time is measured in second. So quantity of charge, its unit is the same thing as amperes seconds or seconds ampere, whichever way you want to pronounce it. But the standard unit that is recognized globally, anytime you are asked in any competition or in any examination for the unit of coulomb, unit of charge, what do you say? You say coulombs. You don't say this. But in some objective questions, that is multiple questions, they can ask you what is the equivalent unit of coulombs. Equivalent means another unit that can be used to replace coulombs. Your answer will be ampere seconds. Let's have a look at this question. It's a simple question to serve as an example on what we have discussed so far. A current of 600 milliamps, small letter M here means milli, and milli simply means 1 over 1000. 1 over 1000. So, passes through a conductor for 1 minute. What is the quantity of electricity that flows? Okay, it is very important that what you are given here, which is in amps, is the what? Current. So, current, which is I, is equal to 600 milliamps. So that means you have to remove this milli and replace it with what? 1 over 1000. That will now be 1 over 1000 times 600. So current I now becomes 0.6 amps. So this is the value we are going to use in our calculation. And we are given time to be 1 minute. Do not forget, you have to convert it to seconds because that's the standard unit of time. 1 times 60, because 60 seconds make 1 minute, and that will give us 60 seconds. Now, according to the formula, we have to find quantity of electricity that flows. Quantity of electricity simply means quantity of charge. Quantity of charge. Remember, I told you in the previous note that it is the flow of charge that is called the study of flow of charge, or the study, yes, that is called what? Electricity. So, in that case, what will now be quantity of electricity, which is written as quantity of charge? You write your formula, current times what? Time. And that will be current, which is 0.6 amps, multiplied by 60 seconds, which is time. And that will give us what? 36 coulombs. That's the quantity of electricity or quantity of charge that flows. In the next episode on current electricity, we are going to discuss about electric circuit, where we'll talk extensively about current itself and some other terms, voltage and resistance. Do not miss that. Thank you for watching.